This week on BSD Now, we have OPNsense 19.7.1 out. ZFS on Linux still has some annoying issues with the arc size that we're discussing. Hammer 2 is now Dragonfly BSD's default. There's NetBSD audio and application perspective we're covering. A new FreeNAS Mini, nice and shiny, we're going to take a look at, and more in this week's episode of BSD Now. BSD Now, episode 310, my new FreeNAS, recorded for the 7th of August 2019. Hello, I'm your host, Benedict Teusling.
And I'm Alan Jude.
Welcome to this week's episode.
Nice Shatner impression you had going there.
Really? We have headlines for this week, as always. This one is OPNsense 19.7.1 is out now. You might remember that we covered earlier release candidates, but this is over now since they have the release announcement here. They start with, we do not wish to keep you from enjoying your summertime, but this is a recommended security update enriched with reliability fixes for the new 19.7 series. Of special note are performance improvements as well as a fix for a long-standing NAT before IPsec limitation.
I wonder if it's specifically why a bunch of other projects don't have their large release happen in July, as opposed to, October or something. It's just to avoid doing the release while people are on vacation. I've never really thought that deep into it before.
It could be a symptom of that holiday season. Everyone's away and they can't patch their software with newer versions. Good to remember that, and if you're in a release engineering capacity in the future. But let's go back to that one. Okay, so the full patch notes are, for the system, do not create automatic copies of existing gateways, do not translate empty tunable descriptions, remove some unwanted form action tags, do not include syslog ng in rc.freebsd handler. They also fixed manual system lock, start, stop, and restarts. They scoped IPv6 to percent sign. They could confuse the NWExec use plan NWExec instead. They allow curl-based downloads to use both trusted and local authorities. And they fix group privilege print and correctly redirect after the edit. They have use for cached address lists in the referrer check. And firewall side, they have HTML escape dynamic entries to display aliases. They display the correct IP version in automatic rules. They also fixed a warning while reading the empty outbound rules configuration and skipped illegal log lines in live log. There's some stuff in the interfaces, like performance improvements for configurations with hundreds of interfaces, and for Python 3 NetFlow aggregator rewrites, so that improves performance.
I'm guessing somebody had a lot of VLANs or something?
I guess so.
Hundreds of interfaces, eh?
That slows things down, but not anymore, or at least it got better. DHCP moved some advanced router advertisement options to the correct config section, and there's some improvements in IPsec as well. They replaced the global array access with a function to ensure the side effect of free boot. They also changed the DPD action to start on DPD action equals restart, and removed already default DPD action equals none if it's not set. Plus, they use the interface IP address in the local ID when doing the NAT before IPsec. The web proxy got a fix for the database reset for Squid4 by replacing use of SSL CRTD with security file underscore certgen. There were some plugin updates for later or current versions, and ports updates for curl, Monit, OpenSSH, PHP, Python, SQLite, and Squid. Oh yeah, that's a well-deserved refresh, I guess. So that's the 19.7.1 release, available now on OPNsense website.
So next up, we have a blog post from our friend Chris Seiberman, who recently replaced some older OmniOS machines with ZFS on Linux-based machines, and is running into some problems. So he says, he'll start with the tweet that started it all. He says, One of the frustrating things about operating ZFS on Linux is that the ARC size is critical, but ZFS's auto-tuning of it is opaque and apparently prone to malfunction, where your ARC will mysteriously shrink drastically and then stick there. I know on FreeBSD and Illumos, there are static dtrace probes configured for when the ARC grows and shrinks and so on to help you be able to diagnose why it is doing so. I imagine those might still be there on Linux. And with the Oracle stuff, it might be possible to dtrace. Although he does mention later on that they're using an older version of ZFS on Linux. So not because of that, but because the reason for that is likely that they're using the one bundled with whatever operating system they're using, means that they might be too far behind to have access to the dtrace stuff that Oracle's brought out to regular Linux.
Yeah, so they need to do some catch up in that specific distribution.
A lot of it comes down to slowly figuring out just where they've moved all the counters to. Like almost every counter that was available in Illumos, I think is still available on Linux. It's just not where you expect it if you're used to Solaris KStat or FreeBSD sysctl. They end up getting broken up into 2 or 3 different places. There's one set that stay in the SPL and one set that stay in ZFS, and some are under proc and some are under sys and weirdness. But anyway, Chris goes on. Linux's regular file system disk cache is very predictable. If you do disk I/O, the cache will relentlessly grow to use up all of your free memory. This sometimes disconcerts people when they see that their free memory is very small. But at least you're getting the value from that RAM. The FreeBSD idiom has always been, free memory is wasted memory. This is so reliable and regular that we generally don't think about it, is my system going to use all of my RAM as a disk cache? Because the answer is always yes. That being the general file system cache, which is also sometimes called the page cache. This is unfortunately not the case with the ZFS ARC on Linux or Solaris. ZFS has both a current size and a target size for the ARC. The target size is called C in ZFS statistics. This is actually a reference to the original ARC paper where those variables names come from. When your system boots, this target size starts out at the maximum allowable size of the ARC. That's not actually necessarily true. So C starts out at whatever ARC max is, but that ARC max is adjustable. And on BSD and Solaris, it used to default to like 95% of all your RAM. It's a bit less than that now, I think. But on Linux, I think they set it to half instead of 90+%. But various events afterwards can cause it to be reduced, which obviously limits the size of your adaptive replacement cache, since that's the whole point. In practice, this reduction in the target size is both pretty sticky and rather mysterious, as ZFS on Linux doesn't expose enough statistics to tell why your ARC target size shrinks in any particular case. This is definitely the thing I miss most when using ZFS on a platform other than FreeBSD, is having the ARC stats, the ones I care about most about, being right there in top and being able to just run top and look at it.
Yes, I look at those a lot.
The amount of information you can glean from looking at that for a couple seconds and just how it's changing over the course of a minute or so is super valuable. There are other tools like ArcStat and Zmon and so on that are very useful for looking at this over time and so on. But just being able to get that quick snapshot from top is super useful. Anyway, he goes on, the net effect is that the ZFS ARC is not infrequently quite shy and hesitant about using memory, in stark contrast to Linux normal file system cache. The default maximum ARC size starts out at only half of your RAM, unlike a regular file system cache which could use all of it. And then it shrinks from there, sometimes very significantly. And once shrunk, it only recovers slowly, if at all. This sounds theoretical, so let me make it practical. We have 6 production ZFS on Linux NFS servers, all have 196 gigabytes of memory, and are manually set to have an ARC max of 155 gigabytes. At the moment, their ARC sizes range from 117 to 145 gigabytes. Specifically, 117, 127, 132, 132, and 145 gigs. On top of this, the file server using the least, the 117 gigabytes of ARC, is the very active one that has the most popular big file system being their mail spool. Even if we're still getting a good ARC hit ratio during the active periods, probably be a lot better if we could use that extra 32 plus gigs of memory that's currently not being used by the ARC, where basically the ARC is shrunken. It's not trying to use it when it should be. So they say, we don't currently have ongoing ARC stats on our file servers, so I don't know if the ARC hit rate or ARC misses are happening and so on. Part of the problem here is not just that the ARC target size shrinks, it's that you can't tell why, and there aren't really any straightforward and reliable ways to tell ZFS to reset it. And since you can't tell the ARC target size, you can't tell why the target size has shrunk, you can't tell if ZFS actually did it for a good reason or not. The auto sizing is great when it works, but very opaque when it doesn't, and you can't tell the difference. I think if you increase the maximum by like just 1 byte even, that can force the C value back up. If not, maybe we should make a tunable to do that. But I've usually not had the problem of getting the ARC to grow back. What I've wanted sometimes is the ability on FreeBSD to clear the KMEM caches, which is memory that ZFS is no longer using, but might use again in a minute. And it's more efficient to keep it as basically cache of a cache. I don't know. It's rather than doing the expense of freeing it and returning it to the kernel, it stays in the ZFS subsystem, but it's not in use yet, and clearing that. But anyway, then we have a PS. Chris writes, several years ago, I saw a memory competition between the ARC and the page cache on my workstation. But then that issue went away. I don't think our file server ARC issue is due to page cache contention, partly because they only have a small ext4 root file system that only has, it's only 20 gigabytes. So even if they cached all of it, it wouldn't take 32 gigs away from the ARC. Even if all of this is completely cached in RAM. Similarly, the sum of the SMEM column from all the PSSs for all user processes is only a gigabyte or two, and there isn't much else happening on these machines. They're just NFS servers. So, why is so much of the 196 gigs of RAM not being used? He does note in a PPS that this is an older version of ZFS on Linux, but our Office workstations run the bleeding edge version of ZL, and they seem to see the same problem, possibly actually worse.
Oh, So that might be something people should look at or try to reproduce.
Yeah, I know a lot of work's been done on and off in FreeBSD on the ARC stuff. I know that before we had the ABD feature, which makes up the ARC out of 4K scatter-gather pages, what could happen is fragmentation. As fragmentation got high enough where the largest chunk of memory available was smaller than in 11.1, it was 1 megabyte, but 11.2 and later, it was bumped up to 16 megabytes because somebody had a problem when they were trying to receive a data set that had 16 megabyte blocks. If it couldn't allocate 16 megabytes, it would hang the receive, basically. Anyway, so when that was still there, ZFS would look at memory fragmentation, and if it couldn't find a continuous 16 megabytes of memory, it would start shrinking the ARC, hoping to make one of those so that they would remain available. But if your memory was highly fragmented, it could go through these cycles where the ARC would collapse, create some of those chunks, then grow up again, and then collapse and grow up again. And eventually, your memory is so fragmented that it would shrink all the way to the ARC min and never actually go back up, because it was still trying to shrink even more because there was no unfragmented memory. And that's where the ABD feature helps out by doing all of those allocations as 4K. It means you have very few allocations that are the big size, and those are temporary rather than long-lived, meaning that you can always have those bigger chunks of memory when you need them. My biggest suggestion to Chris would just be you could set your ARC min to something like 140 gigs and then only let it go up and down in that 15 megabyte range or 15 gigabyte range. But that's maybe not great either.
So is that the compressed ARC already, or is that a too earlier version that didn't have that yet?
This would be all the math is based on the actual physical size. The compression is there,
but for the sizing, it's not been taken into consideration. Yeah.
Yeah, the size of the ARC is all based on how much memory it actually takes. The compression is just a free win after that.
Okay, so if someone has an idea, then send Chris a message, and or if you have similar experiences, then report this upstream. So this might be something more people in their systems are seeing, and this might point to a general problem. Up to our news roundup this week. We have Hammer 2 is now the default on Dragonfly BSD.
This is the installer default, switching from Hammer 1 to Hammer 2.
Exactly, yeah. This is what Matt Dillon writes in his commit message. And he also adjusted the end release build to print the location of the image files when it finishes. And that change, and you can find the details on Dragonfly BSD's GitWeb. So yeah, that seems like a Hammer 2 is now mature enough to be used in the default installation, and they kind of did away with the Hammer 1, which was also a good file system, but I guess Hammer 2 supersedes that now and is the default in all new installations from Dragonfly. Then we have something for the audio aficionados out there, NetBSD Audio, an application perspective. This is over at the NetBSD blog.
So this is from Package Source Con, and it's Nai Alare's first talk. So talking about the audio options for NetBSD in Package Source. You can either use the NetBSD native audio, as in the audio.io.h, or use the OSS emulation layer, basically a wrapper around the Sun audio in the kernel, but it's incomplete and an old version, but works for most simple things. There are also many abstraction layers available, including OpenAL Soft, AlsaLib, libAO, GStreamer, Port Audio, Pulse Audio, Jack, SDL, etc., etc., etc. But the advantages of using NetBSD Audio directly is that it's lower latency and uses the least CPU. The abstraction layers differ in latency. SDL2 versus ALSA and OpenAL have very different latency. You can query device information, for example, just ls dev audio 1, a USB microphone, or some sound card. And you can avoid bugs from excessive layering. If you're going to have so many layers, that's more chance of something going wrong. It also has a nice API that's well documented, but they note, I had no idea how to write audio code. I read the man page, and now I do. And they note that your code might work on a Lumos as well.
Oh, even better.
Yep. So their first test case was a program called RetroArch, a front end for libraries implementing emulators or game logic. Learned that NetBSD had its own non-OSS audio API, and I wanted to increase support for it. RetroArch was a straightforward target, and they accepted the patch upstream, and this code also works on a Lumos. So good cross-project participation there. Then, what are the differences from the OSS implementation? Importantly, the kernel calculates the block size for the user's global latency. The smaller and probable results are more desirable outcomes, and there are fewer ioctals. OSS passes values via setters, whereas Sun passes one struct to the kernel to set everything. So you don't have to make a whole bunch of these expensive calls just to set up the audio. They do say that both Sun and OSS involve opening a device in /dev and performing standard read and write operations on it. The difference is how you tell the kernel what to do with the data you're reading or writing. Next up is their second test case was AIO Mixer. So they decided to use their experience after RetroArch to write a mixer, because the state of audio mixers is quite lacking. a lightweight, user-friendly alternative to Mixer CTL was what they were after. They wanted to do more than just change the volume, like DACs. Your laptop has a headphone port and speakers. Should be possible to select between them and control them independently. And it'd also be nice to have more readable DAC names. And so they actually have a GitHub project here where they have their AIO mixer work in progress. Then they also looked at SDL2 and re-implementing some stuff of that. They looked at QB, which is for Firefox and SeaMonkey. Basically a portable audio library written in C and C++, mainly used by Mozilla. And Mozilla recommends Pulse Audio, but upstream accepts patches for new backends if the tests all pass. So the poor native audio support, only an unofficial OSS backend with no support for microphones or device selection and so on. And I found that even FreeBSD removes support for it. So they wrote a QB backend for the NetBSD audio subsystem, which can detect your microphones and so on. And they show here an example of the web browser of enabling your microphone using it.
Hey, that's progress, yeah.
Very nice. And they note that the little asides added at the bottom of some of these sections are based on questions that were asked during the talk, which is an interesting way to do that.
And yeah, they're looking for a job apparently. So so thanks for that. It's certainly interesting to watch that. And maybe we have a future episode with more news in that area. But now, the big news. There's a new FreeNAS Mini available over at the IX Systems blog.
Actually, 2 of them.
Oh, 2? Can't get enough of one. Just make 2 new ones. Excellent.
Yeah, so they've made the FreeNAS Mini E, which is designed to be even more low power. So the Mini E gives you a 4-bay platform for your regular, small office or home office. Provides 4 gigabit Ethernet ports and 8 gigabytes of RAM. Lets you do file sharing, streaming, transcoding, etc. And starts as low as $749 for just the chassis, or configured with 8 terabytes of capacity for only $999. And it only consumes 36 watts of power.
That's good.
But they also lent the other way because, most people have needs that are a little bit bigger now. So the FreeNAS Mini XL Plus is a new powerful platform that gives you 8 3.5-inch bays, plus a hot swap 2.5-inch bay and an internal 2.5-inch bay. So you get 2 SSDs that can go inside of it, plus 8 hot swap hard drives, which provides the latest compact server technology. In addition to a beefier CPU, it also provides dual 10 gigabit Ethernet, 8 cores, and 32 gigs of RAM. And because of the 8 hot swap bays, it means you can scale beyond 100 terabytes of space. So even the most demanding applications, 100 terabytes of space and 2 times 10 gigabits and 8 CPU cores and 32 gigs of RAM, that's a pretty decent machine.
Yeah. That can do some pretty much long and cool storage work. It's not a mini in itself. It's just a big one, a biggie.
Yeah, well, it's the Mini XL, the same size as the Mini XL. You just get 10 gigabit instead of less, a newer, faster CPU, more memory, etc. It starts at $14.99, or you can get a fully configured one with cache SSDs, and 80 terabytes of capacity for $42.99, and all in a power budget of only 100 watts.
Yes, your electricity bill will thank you.
Mm-hmm. So that's both of those are very big updates to the FreeNAS Mini line. So they now have a smaller, even less expensive one. If you only need 8 gigs of RAM and going to do something at home or at the office, but if you were going to run your VMware stuff on top of it or something, you can get the Mini XL Plus, which provides up to 20 gigabits of network capacity, 32 gigs of RAM, and can do, up to 100 terabytes of usable capacity for under $5,000.
Mm-hmm. Yeah, I can think of a couple of good use cases for that one.
Mm-hmm. It's a very nice refresh. There's a link, a review of these over at Serve the Home, where they go into the details about exactly what's included and so on. But you get ECC memory, remote management via IPMI, and all the stuff you need.
Yeah, and the usual management software that you are known that you
yes.
expect from IX.
Well, and with their new True Command thing, you can manage multiple FreeNAS, whether they be Mini, Mini E, Mini XL, XL Plus, or just your own home-built FreeNASs. You can manage them with True Command.
Oh, excellent.
And True Command is free up to some number of hard drives total. And if you have more than that, then you buy a subscription. Yes. If you have less than 50 drives across all your FreeNASs, you can use True Command for free.
Yes, that's where the pricing starts if you have more. Okay, but it's a fair entry thing.
Well, yeah, 50 hard drives is a lot.
yeah, definitely. You need to grow quite large, and then I guess by that time you can not only afford hardware but also the subscription. Okay, yeah. So congrats to IX Systems for two other nice systems that people can put under the desks or in the offices and start storing data on it.
Yeah. So they have an even cheaper one now if you want, and super low power.
So time for the Beastie Bits this week. We have a nice welcome from NetBSD to version 9.99.1.
Yeah, so this is basically what will become NetBSD 10.
Mm-hmm. They're almost, there at...
Instead of calling it 10 current, they call it 9.99. It has the advantage of their AVI number doesn't... Like, the first release of FreeBSD 12 has AVI number 1200086, because there were 86 changes during the current version. Whereas if we had called it, 11.99, then we could have started at 12.0.0.0.0. So I kind of actually like the way that NetBSD does that.
Mm-hmm.
But yes, they've started the branch of what will become NetBSD 10.
Yes, and that will result ultimately in a release. And if that happens, we'll mention it here. And if there are betas out there or release candidates, we'll let you know so you can test and provide feedback, because then the stuff that you find will probably not be in the release. Then we have found the Berkeley Smorgasbord Part 2. Okay, but this Part 2 mentions OpenBSD, which makes life pretty easy when it comes to securing your web app. And then in this post, they go through the following steps. The first, to secure the traffic to foobar.com and cdn.foobar.com, their asset hosts. And then the second, just to have a plain text traffic to barbaz.com. And then a third, make sure that their TLS certificate gets updated automatically via the cron job. So
they say we will be building upon the previous post, which was basically installing and configuring OpenBSD, and assume that the state-of-the-art server is in a place where they left off in the previous one, meaning your foobar web app is humming away via RelayD, HTTPD, and your Erlang. It also assumes that Let's Encrypt CAA DNS records are in place, that port 443 is open on your box, and that doas is what you're using in place of sudo. So first, they're going to start by backing up their RelayD and HTTPD configs in case this goes wrong in some way. Next, they're going to build on the existing httpd.conf from the first tutorial to make it handle HTTPS and make it answer the Acme client challenges. So they have the server foobar.com with the aliases www and cdn. Going to listen on a port, and then they're going to make a directory var www acme and set up the Acme challenge directory. Redirect all other non-Acme client requests away from that. Then they're going to set up listening for foobar.com on port 8443 and redirect to the version without the www. And then if you come into cdn.foobar.com on port 8001, they're going to read from the assets directory here. And then they also set up barbaz.com on port 8080.
Oh, that's a nice tutorial.
So it says this file is now ready to be used in conjunction with Acme Client to automatically answer any requests. So after they set up the directories, they can configure their acmeclient.conf and basically say, hey, foobar.com, which is also www.foobar.com and cdn.foobar.com. Here's where my private key and certificate are, and I would like to sign with Let's Encrypt. Now, although RelayD isn't ready to serve our web app over TLS, that doesn't mean we can't get our certificates. So they get that running, run the Acme client. It makes the request, Let's Encrypt connects to the web server and verifies that it's actually your website. And once they know that it's your website, they will issue the certificate. And then you can start up your HTTPD and it'll have access to the certificate.
Mm-hmm.
So he says, what did we just do? And he explains how that works. And now there's a bit of hacking needed to get RelayD to work with TLS. So they'll start with a work in progress relayd.conf. And you can see they have its listing on all of its IP addresses on port 80. And then connecting to apps on port 8000, 8001, 8080, and 8443. So you can see that apps go to port 8000, CDN go to 8001, all the websites are 8080, and the TLS websites are 8443. Then they make the HTTPS filter and configure that, set up their proxies so that anything coming in on the RelayD address and plaintext port goes through the HTTP filter. But anything that comes in on port 443 with TLS will go through the HTTPS filter. And now RelayD will take care of basically being your SSL terminator.
Mm-hmm.
So then they also configure strict transport security, which basically says this website will always have TLS and the browser should warn the user if suddenly the site is trying to talk to you without it. Then they get into some of the more nuanced stuff to set up the default certificate. So what happens if somebody connects to 0.0.0.0? Like basically, if someone connects to the IP address or some unknown host name, we want to be able to present the right SSL certificate. And then they set that up and restart RelayD, and it's good to go. And then they use curl, and they can actually make sure that this all works. They also recommend you can check out securityheaders.com and sslabs.com to verify that all your configuration is right. Then just cron tab running Acme client on foobar.com and reloading RelayD so that every 60 days when you refresh your Let's Encrypt certificate, RelayD will load it, and you're good to go.
Then next up is detracing Postgres. We found a video on YouTube that does just that.
Yes, this is from PGCon, the Postgres conference that's related to BSDCan. And so this has got live examples of flame graphs and so on from inside Postgres.
Yeah, to analyze the latest database queries or bottlenecks that there might be. Yeah, because I know dtrace probes are built into the Postgres source, so you can use their native probes rather than just use the ones that the operating system creates for you. So you can really see, okay, transaction begin, transaction end, transaction abort, or really detailed parts of the database system internals, because the Postgres folks actually put it at the places where you actually want to have them. Cool. Yeah, something to watch later. Next up, we have Project Trident 19.07-U1 is now available.
So apparently a recent change in libpci access is causing problems with the Xorg VESA driver. And they're saying that this particular snapshot of TrueOS 1907 will only work under UEFI for the installer. So their graphical installer only works if you have EFI. If you have an already installed system that you're just upgrading, as long as you have some kind of graphics driver, you'll be fine. But if you have no graphics driver, then you should hold off and not update this version just yet, while Upstream works on figuring out why the VESA driver isn't working correctly, and also looking at some other install method that doesn't require graphics. So maybe a text installer for TrueOS or Project Trident.
Okay, yeah. And they mentioned that the HAL is now been blacklisted by them, which causes some of the ports not to build that depend on the HAL port. They have a little history about why HAL was placed into the blacklist because, there were apparently some issues with it. Also, the bald eagle exploit.
Yeah, so HAL went into maintenance mode, meaning not getting active development back in 2008. The current version in ports is from 2010. The last commit to its source code was in 2011.
See where this is going, and now there's security concerns with HAL, including the bald eagle exploit, which was revealed in 2017. And as a side effect now, they write that they're blacklisting the HAL port, and all ports which have an explicit dependency on HAL are automatically ignored by the package build system and will no longer have packages available. Some of these packages include the XFCE desktop environment, the Mate desktop environment, GNOME desktop environment, Cinnamon desktop environment. So that's kind of bad for a graphical desktop distribution.
Yes, losing a large chunk of the graphical desktops is possibly problematic.
And so, that people should be aware of. But they also list a couple of new packages and package upgrades. So definitely check it out. And if you don't run any of those desktops, you should be fine.
Yes, and I see, in their list of packages that were deleted, there's quite a few GNOME-related ones.
Dependencies and sub-dependencies, Okay, but definitely something to watch as an update if you're running Trident. And last but not least, in our Beastie Bits, we have need a secure operating system? ? Take a look at OpenBSD from Dev Pro Journal.
Mm-hmm.
And they have a section in their technology trends part in there. The Unix-like OS offers support for a wide range of hardware platforms, third-party tools, and an active supportive community. That's their subheading.
And basically, it goes on to say, Joseph Wolf, the founder and CTO of ERAC Systems, which provides OpenBSD-based firewalls, laptops, systems installs, and consulting since 1999, says OpenBSD was and is written from the ground up with a security-first mindset and goal, making security the first priority. The core OS and core packages are also security audited as well. He says that OpenBSD features a minimum attack surface, including minimal installed packages in the default installation and as few open ports as possible. And they have a list of some of the included third-party software on top of what you get with OpenBSD, including their version of Xorg, LLVM and Clang, GCC, Perl, NSD, Ncurses, binutils, and GDB. And then a bit about the famous OpenBSD tools, including OpenSSH, OpenBGPD, OpenNTPD, OpenSNMPD, LibreSSL, and Mandoc. A little light on detail, but a good overview of what you get from OpenBSD. They also have a link to the OpenBSD journal over at undeadly.org, which always has interesting stuff happening in OpenBSD.
Yeah, things like hackathons and updates.
Interesting one I just saw. There's an OpenBSD Unveil package for Perl on OpenBSD now. So you can use the Unveil stuff inside Perl.
Yeah, check out the full article and OpenBSD afterwards. So now it's time for feedback and questions. And before we get into them, we should mention that you send us feedback to have a future section that is filled with questions like these, or any other things that you want to talk about, any stories that you find that are worth mentioning in a future episode. Send all this to feedback@bsdnow.tv, and that's the way to reach us, and then we'll have future content in this section. The first one this week is Jeff with feedback on the OpenZFS port testing. Jeff writes, "Hi, I'm a relatively new listener and so far enjoying the show. Thank you, that's good to hear.
Mm-hmm.
I appreciate the depth that you provide on technical topics and appreciate the breadth of coverage for news items across the BSD landscape. I have dabbled with FreeBSD off and on since around 2004, 2005, but my professional background since 2006 is Linux and HP-UX. I was rather interested in the recent show topic, episode 303, about the OpenZFS port for FreeBSD, and so I decided to install 12-stable and give it a shot. Compiling the port is obviously no problem, but one issue I have run into is a dearth of information on how to ensure that the OpenZFS kernel module is actually loaded and working correctly. Thus far, I have really only managed to break my system by changing ZFS_load equals yes to OpenZFS_load equals yes, and then being unable to boot because the root file system is on ZFS. I admit that I may have done things backwards by installing the port and then doing the build kernel. Are there any dependencies on recompiling the port against the recompiled kernel? He only uses generics, so he's not sure if that would matter, but he's not fluent with BSD, as he's more with Linux. Presumably, had he done everything, would he have seen the OpenZFS module loaded instead of ZFS in KLD stat? And if that's all that's required, should this be not done on root file systems for the time being?
So it should work on root file systems for the time being, although for testing, it might be helpful to have a not root file system. So for rebuilding with build world and build the kernel, if you were already on 12 stable, then what were you rebuilding? So you don't have to compile the port after you do build world and build the kernel, but the port is built based on what is in /USR/SRC when you compile the port. So if you compile the port, then update your source tree and run build world build kernel, that kernel module is not going to match the kernel you just built and won't work. So you need to make sure that you build the OpenZFS module when the source tree is going to match the kernel you're going to try to boot with it.
Yes, otherwise the interfaces and APIs, KPIs don't match and can't work together.
Right, and then the kernel module will fail to load, and and
then there was a question in the episode about preferences that users might have in favor of a switcher script, and that's Jeff's suggestion, as that gives him the admin control over which set of ZFS tools to use, and also provides a consistent set of commands.
Likely is that, your module just didn't happen to match up. I'm curious what you were doing a build world build kernel for. Like, did you install from a 12 stable snapshot, or did you install like 12 and then upgrade?
The source, yeah.
But yes, the other thing is, while you can build kernel and install world and so on from any directory, ports always build against user source unless you set an environment variable I cannot recall the name of off the top of my head. So you want to make sure what's in user source is going to match the kernel you're going to be trying to load the module into, because it has to match or it won't work.
Yeah, but definitely good that you want to help out testing and also see what's new in OpenZFS coming down the road. And thank you for your feedback about the podcast. And if someone else has something about this, then send us a follow-up question. Or if you succeeded with that and stuck into another roadblock, then you can also send us some follow-up. Okay, thanks for that. There's Malcolm next with best practices for custom ports. Malcolm writes, hello. Is there a best practices for if one wants to have their own ports that don't necessarily need to or can be brought into mainstream? For example, if I want to take an internal project at work and make it a package to install. Do I need to have a copy of the entire ports tree and have a patch set on top of that? Or can I have some kind of bare ports tree that I can put my ports into? Thank you.
Yeah, so there's basically two different approaches for that. The one is you can do something like create your own category and put all your ports in it and keep that separate and do it that way. Or you can do something like a git clone of the ports tree, add your stuff to it, and then occasionally just pull in all the ports from upstream and merge them. So there's a tool called Port Shaker, which is designed to let you maintain a set of ports trees. And basically, a single target port tree can contain ports from any number of source ports trees. So Port Shaker lets you have, your custom stuff in one repo and the official one over here, and combine them into one port tree when you go to build packages and so on. So yeah, Port Shaker might be the tool you're looking for to maintain your bare repo with just your ports in it, and then apply that over top of the default FreeBSD ports tree. Or you can clone the FreeBSD ports tree with Git, apply your changes to it, and then just periodically merge in all the changes from upstream and maintain a ports tree that way. Both are perfectly acceptable. It kind of depends on your preference and how you want to do it, and how often you need to do it, and so on.
Yeah.
So yeah, Port Shaker is probably the fastest route if you want. If it seems like that was the way you're already leaning with having, a separate bare ports tree with just your stuff in it, and it lets you just kind of overlay that on the regular ports tree and have it work. So check out Port Shaker, all one word.
Okay, yeah. So good luck with the porting. And last is Michael with a little connection. It's short and sweet. Michael writes, as always, good show. One day a week, my computer's better than the others because of BSD Now. Thank you. Well, really thank you for listening.
Mm-hmm.
And we mentioned a PDP 11-884 running BSD 4.11. Actually, all PDP 11s are 16-bit processors without a paging MMU, and thus only ran BSD 2.x. BSD 4.x was 32-bit only, and the virtual memory system required a paging MMU.
Yeah, so while I was reading from the link, I halfway through the line jumped down to the next line and read the wrong version number. When I first got this email, I was sure I had said it right. And I had to go back and listen to the episode and hear myself say it wrong. Be like, oh, okay. So yes, I misspoke when reading that one.
But someone noticed, and that is now corrected hereby.
But also good explanation of what the difference between BSD 2 and 4 was, and so on.
Yeah, it's kind of doubling of the bits, basically, with the version.
It's also interesting that both FreeBSD and regular BSD both had very short-lived version 3s. Yeah,
that's true.
I'd never really thought about that before. It's not like it matters.
Yeah, so that's this part, and that pretty much wraps up our feedback and questions section, as well as the episode. Stay with us, enjoy your commute, or wherever you are listening to us, and as always, thanks for listening in. And again, send us anything that you have about a future episode, feedback, show notes, ideas, topics, comments to feedback@bsdnow.tv, and then we'll see us or listen to us in the future.